It's wonderful to be here and great to meet all of you. Today I want to talk about what could be the next big frontier in computing. Something that I think could unlock massive opportunity for the investors, developers, and entrepreneurs in this room, but also potentially help us to answer some pretty big questions. And that is the proliferation of ubiquitous, massive-scale simulation. So why is this important? What kind of questions can it help us to answer? Imagine for a moment the coming disruption with autonomous vehicles. Now, these are going to change the world in huge ways. What if we wanted to try and understand, to quantify, to think about how autonomous vehicles are going to disrupt our cities and our nations? Well, we'd have to consider a lot of different factors. I mean, quite obviously, autonomous vehicles will change how transport networks work. But beyond that, they're going to start to change how we think about land use. What's going to happen to all of that spare parking? They're going to affect complicated systems like economic activity within urban spaces, even crime and policing. To really start to quantify and understand how that disruption is going to take place and what it's going to do to the world, I mean, that could be a pretty big opportunity. Some people in this room might, by unleashing and understanding those consequences, start to make the next big unicorn companies. Cities and governments might change how they operate to start saving enormous amounts of money if we could know the answer to that question. So how might we answer it? Well, normally, I think this will be quite familiar to a lot of people here. Normally, we would attack this problem with data, right? Big data and machine learning in particular. And we might imagine that there is some massive volume of information that we could harness out there that we could use to start changing how we attack this problem, or perhaps even run some interesting regressions and think about how we could extrapolate patterns into the future. Well, we can't. We can't solve this problem with data alone, because we're trying to understand something about the future. More importantly, we're trying to understand something about how dozens of complicated systems interact with each other and how we might be able to manipulate them. So, in the end, when trying to do this, when trying to ask what-if questions about the future, we can't rely on the systems and patterns that we've used before. And there's a reason for that, too. It's because we're dealing with what in science are known as complex adaptive systems. Millions of entities interacting, just like in this room, like all the people that are here talking and going about their business. Their individual behaviors give rise to the complex phenomenon that we are interested in studying and thinking about. So if we really wanted to know how an autonomous vehicle might affect a city, or how a change in policy might impact an urban space, we're going to have to recreate the entire system. Let's think about that for a moment. What if we could do it? What if we could create a digital city? Billions of modeled and simulated entities interacting with each other, representing a transport network, waste disposal, power grids, synthetic populations. What could we do with that kind of power? I mean, we could start to do what-if questions around launching a new product, or some clever new strategy for routing vehicles around. Or we could try and imagine what would happen if we redesigned or built new cities or built new urban environments. And actually, if we had that kind of power, why not go further? Why don't we try and model an entire social network, hundreds of millions of interacting entities? Why don't we use that to try and figure out why a phenomenon like this took place? Maybe we could even harness that power to engineer our own viral spread of new ideas. How about an economy? Maybe we could have anticipated or even thought differently about the responses to different financial crises if we could have actually modeled and represented the phenomenon at work. How about your company? In the end, all the processes, people, and mechanics that represent a business, they can be modeled just like a city could be modeled. Maybe we could use that to start asking what-if questions about how we might optimize and improve and unlock value within businesses. Now, I imagine this is already kind of interesting, but I'm sure a lot of people are skeptical and might require a little bit more motivation. So I want to talk about something we're all familiar with, VR, right? So tens of billions of dollars have gone into the world of VR, and we're all very fascinated with the devices. I'm personally very interested in waiting for my Oculus as well. But in the end, VR is a portal. It's something you put on that takes you to another world. But to what kind of world? Well, unless we can solve the problem of simulating massive spaces, we're going to be going to a very limited and lonely world, a place that is quite pretty, but where there is little for us to be able to interact with, little for us to be able to do beyond simply exploring this pretty space. But that's not what we want. We want the Matrix. We want the oasis from Ready Player One. We want to put on those headsets and go to vivid, magical worlds that are the same kind of complexity as the cities and massive economic models that we've just been talking about. So if we want to unlock all that value and all that potential, we need a way to start simulating billions of interacting entities in real time at massive scale. That's what we're going to need to unlock this opportunity. And if we could do it, well, wow, what could we do? What could we not do in an environment like that? The trouble is, we can't do it today. The simulation that we have today just isn't ready for this sort of use case. In many ways, simulation today is where data science was in the 1970s. We're at the point where certain scientific groups are using it to solve certain core problems in physics and other areas, but it's not something that the developers and entrepreneurs in this room can step out and begin to use. We couldn't begin collaborating on building a model of a city or building game worlds like we just talked about. A lot needs to happen to make that happen. Let's try and think about some of the differences. Why is it easy to scale big data, but not scale simulations? Well, when we're dealing with data, we're actually dealing with computation over relatively static information, right? We want to do a big query, or do a big search, or do other sorts of large-scale operations. Simulations are different. A simulation is a model that is actually generating data over time. If we were to model an entity like a car or a person in a city, that entity is behaving, acting, moving around that virtual environment. We managed to scale up the problems in data by creating an enormous amount of infrastructure in the last 10 years. Systems that everybody in this room relies on today to be able to do those big queries. But actually, and this is where I want to introduce this idea, if we wanted to do something similar with simulation, we would, let's imagine calling it strong simulation, we would need to solve a completely different set of problems. Scaling simulations is like, it's like trying to scale up a gigantic circus full of thousands of badly behaved circus performers, clowns, and interacting agents. It's an incredibly difficult computational challenge. It's not just about building lots of infrastructure. It's about totally new ways of thinking about designing algorithms, of thinking about creating APIs, of thinking about unlocking opportunity, which today would require a totally new approach. And in our view, it is the next big frontier in computing. You're going to start hearing about more and more companies attacking these problems. But what would be required to actually make this a reality? Well, to unlock this, we're going to need totally new infrastructure. We're going to need smart scaling services that can cope with the dynamics of a running simulation. We're going to need an easy way for developers to code it. And we're going to need a way to be able to reuse all of the incredible models that we already have. Things like game engines or traffic simulations. We're going to need a way to put them all together to create these new applications. So this could be a massive challenge. It could take a long time. It could be something that we all find very difficult to build and to make into a reality. I'm pleased to announce that over the last 2 years, myself and my colleagues have been building exactly that. And for the first time, we're happy to talk about our new operating system, SpatialOS. This is the world's first large-scale distributed operating system. It runs in the cloud over a body of hardware that the developer doesn't need to think about. You can build applications which at their core have overwhelmingly powerful simulations, and you can build and scale them as easily as you might create web apps. For the first time, we've implemented a totally adaptive infrastructure. So as a game developer or scientist begins to build an application, behind the scenes, these servers can reconfigure themselves to cope with instantaneous load. We can cope with failure. We can cope with the demands of millions of live users interacting with the simulation. How do you use it? Well, it's going to be really, really easy. You just download an SDK, very simply from a website. You begin integrating any model that you're already familiar with, things like the Unity game engine or popular traffic simulators or any number of other applications. And then with a web browser, you can deploy, push, and launch applications that can run across thousands of servers that previously would have been the purview of very few large cache and large-scale projects. Now this can be available to basically any developer that wants to harness that kind of power. And the nice thing is, you don't have to think about infrastructure. You don't have to think about distributed systems. You don't have to think about networking. None of those challenges occur when you use this approach. All you need to do is build the model that you're excited by and that you're interested in. And an interesting thing for the developers in the audience, for the first time, we can hold in memory a massive live universe, a huge data structure that you can interrogate and play with to build all kinds of applications, even going beyond what we can do in the examples of simulation that we've given. So this is a platform. And it's something that we hope people will look at as a way of beginning to run and operate the businesses of the future. Companies can actually leverage SpatialOS applications to drive decision-making or to help them completely look again at complex systems. Another little point to mention, anything you build with SpatialOS can serve millions of users. The platform understands how to scale your simulation and serve it out. You can plug in all kinds of devices, VR headsets, mobile phones, anything that you want to interact with the application. Hello World, for us, is an MMO. The simplest thing you can build with Spatial is something that can already captivate a huge audience. So another thing that I'm really pleased to talk about today is that it's already in the wild. We've been quietly working with some incredible people to build totally new kinds of applications using Spatial. And we'll be talking a little bit more about them today. One of the ones I'm most excited about is Worlds Adrift. And my good friend from Bossa Studios, Imre, Jele, he's been working for a year now on an incredible new virtual world that for the first time features a persistent landscape the size of Israel or Wales. It features tens of millions, in this demonstration 4 million, but far more than that in a final live deployment, of interacting entities, creatures forming their own ecology, a persistent world where your actions affect the outcome. And I wanted to invite him up in a moment to show you a little bit more about the game and to talk a little bit more about it. But before I do that, I'd love to show you. This is Worlds Adrift.
Hello, I'm Imre. I'm from Bossa Studios. We are making this game called Worlds Adrift. There's a lot of things to say about that game, and if I may say so, I think this is awesome. But of course, I would say that. But one of the most interesting things is that this game, and by the way, everything you've seen on that was real-time capture from a multiplayer game environment, including physics, the clouds, the winds, everything. One of the interesting things that for the vast majority of development, we only had 5 people working on it and being able to create this. Even now, when our team is huge, we only have 15 people involved. Now, there are 2 things which I wanted to tell you today about. Firstly, is that what SpatialOS allows us to do is to create this gigantic multiplayer environment driven by physics, driven by a clever AI, and more importantly, this is a persistent environment. As you've seen in the video, we blew up a giant ship, parts flying around. Every single bit of that ship will stay around forever in the game universe until someone removes it. The entire environment is persistent. If you leave something there, it will stay there for an hour, for a year, until someone moves it. This is huge, because players are not only going to be able to visit this fantastic universe, but they're going to be able to leave a mark on it and change to their liking. The second thing I wanted to talk to you about today is, I believe, quite important. We dreamed of this game for a very long time. We wanted to change how large-scale multiplayer games work for many years, and we couldn't. It was impossible, not just for a small indie team like ours, but for anyone. When we met the Improbable team, we realized that actually this vision we had is actually possible to realize. We are not only dedicated to create this game using SpatialOS, but we're also dedicated to help others to create that. To that effect, I'd like to announce here that the code base of Birds Adrift will be open source. This means that any other developer who is interested in getting into the game not only will be able to mod our game, Birds Adrift, but will also be able to take elements of the forked code and start to build their own game pretty fast. What we are hoping is that we are in the beginning of a new era of multiplayer games. And what we hope is that our work is just going to be the first step and help many others to create amazing multiplayer game experiences. Thank you.
And I wanted to go a little bit further too, talking to you about some of the things that we've been building with SpatialOS. We're currently working with the Smart Cities Catapult and Core Transport Mobility Catapults in the UK to create a complete representation of a British city. We're starting to broaden that project out now to work with various academic groups and companies, and the entire code base of that framework is going to be available to any developer that uses SpatialOS, just like all the code for Worlds Adrift and many other projects that are beginning to be developed on top of our platform. I'm really excited to announce we're also now helping to work on grant proposals for a number of different institutions around the world in areas ranging from modeling the rainforest to looking to create new economic models of the housing economy to areas even as deep and complicated as cellular biology. And all of those models, as part of our academic program, are going to be available to anyone, commercially or otherwise, on our platform. So it is the best possible time to start imagining that business that you might be thinking of starting based on simulation, based on the kind of infrastructure that we're going to have out there. This is a totally new space, and we're going to need your help to really understand it. We're looking both for developers that want to play with the technology, but also service providers who already have applications that they would like to integrate to start serving our whole community and to make them part of big simulations. If you have a game engine, if you have a simulation, a model, or a device, start talking to us about how it can become part of this platform. I'm really, really pleased to announce that signups are starting today, and the first remote users will be rolled out over the next couple of months. So thank you so much for listening. We're very excited to start this whole journey with all of you as well. Thank you.
They're going to sit down, and then I'll just join them. They'll
Cool.
sit down. I'll figure out
I think we now have a Q&A.
Okay. Thank you. Herman, you want to talk for a second?
Sure.
About this? Okay, I have three questions. First of all, it's effing cool, got to say. That which I understand of it. The big question is, who is going to be hurt the most by this? Like, who is going to really feel disrupted, put out of whack by the ability to do this?
Well, one of the big things that we're doing is we're going to disintermediate all the cloud providers with what we're offering. So a developer will only really need a SpatialOS account, and they'll be able to start building applications without thinking about hardware. So there's no need to do a lot of the managed hardware work that developers do today. Much of that will now become more of an infrastructural layer. So it may not put people out of business, but it may make people reevaluate, if we are successful, how they deal directly with developers.
Okay. Second question is, who do you think is going to most benefit? Like, which sectors, which kind of people? I think of hedge funds modeling the economy to make a little bit more money than they're already making. Is that who we're talking about? If that's all it is, I hope that's not what you're up to.
I think the implications could be really profound. I mean, we're already talking to governments, people involved in massive logistics operations, disaster relief, population modeling to look at how we can reduce issues like crime and other kinds of disruption in urban spaces. There's even defense implications that we're only now beginning to explore. I think this is a whole new frontier, just like big data and machine learning were. And despite whatever benefit we might get as a company from building this infrastructure, we hope sincerely that it is explored and that its implications and value are really realized.
So it doesn't compete with machine learning systems?
No, it's
artificial
very complementary.
It's very complementary.
It's very complementary. Simulation is a totally new approach to knowledge. You build a real model of the thing you want to study. You can still use machine learning and big data to help inform that model, but it's a different approach.
OK. Thank you very much.
No problem. Thank you.
All right.